Jai Hind everyone. So today we are going to discuss subject network analysis and synthesis. Subject code is KC303 and we are going to discuss topic mesh analysis. So first we will see what is mesh. So there is a slight difference between mesh and loop that all of you may be knowing before your this discussion also, because these things are the basic things that you must have studied in your basic electrical engineering, but we will recall this: what is mesh, what is loop, what is the slight difference between those two, and then we will go through this mesh analysis. We will see how this mesh analysis is beneficial for solving the network. Okay, so as we see the circuit on paper, we can simply by observing that network, we can focus that which analysis we will apply. If in question it is mentioned that we need to apply mesh analysis, then we will have to apply mesh analysis. But if it is not mentioned in the network that which analysis we should follow, then first we should take a look of the network, that what is the structure of the network. Okay, so basically there are two basic analysis of this type, that one is mesh analysis and another is nodal analysis. So these two analyses have equal importance. Okay, we cannot say that mesh analysis is superior over nodal analysis or nodal is superior over mesh analysis, but by simply observing network, we should initially analyze that which method will be easier, okay, for the given network. So like if in circuit number of parallel paths are more than the number of loops. Okay, so if we see the structure of the network and we find that there are more number of parallel paths in the given network, then we should go for the nodal analysis. Otherwise, we can opt for the mesh analysis. Both analyses have equal importance and we can apply both analysis into AC network as well as in the DC network. So let's start with our discussion. So what is mesh? Okay, so mesh and loop, there is a slight difference. Okay, so mesh is a loop that does not consist any other loop inside it. Okay, so we can say in other words that mesh is an independent loop. Okay, so independent loop is the mesh. So mesh will not contain, it will not consist any other loop inside it. So mesh analysis technique, why we use mesh analysis technique? So it is used to measure the mesh current as variable. Okay, so here in mesh analysis we take mesh currents as variable. Okay, so in each we will see through the numerical problem also that in mesh analysis mesh currents are the variable. Okay, so what we do in other analysis, in basic analysis that you have studied up to your class 12th, what we do in that, we consider a current through the element as variable. Okay, but here we consider mesh current and that mesh current is the variable instead of currents in the element. Okay, so therefore this method will be easier. Okay, so it will absolutely it will reduce the number of steps, number of equations that will be involved for solving the network. So mesh analysis applies KVL to determine the unknown mesh currents. Okay, so in the given circuit we will assume mesh currents and then we apply KVL in the mesh, okay, or in the loop also to determine the unknown mesh currents. Okay, so this mesh analysis is also called as mesh current method or loop analysis method. Okay, so this is also known as mesh current method or loop analysis. So after finding the mesh current, what we do, we assume individual current in individual mesh and then we apply KVL in the mesh. So then we will be having number of equations that is equal to the number of mesh. Okay, suppose there are 3 meshes in the given network, so we will be having 3 equations. Okay, so all these 3 equations will consist of unknown currents. Then after solving those equations, we can find the mesh currents. Okay, so if we able to find the mesh current, then we can calculate the power, we can calculate the voltage in the given circuit anywhere. Okay, so if we need to calculate the power absorbed in any element, then if we had calculated the current through that, we will square that current, I square into R, that will give the power absorbed by that network element, or current into the resistance of that element will give the voltage drop. Okay, so this is how, see, suppose I am drawing this circuit for example. Okay, so here this is a very simple network. Okay, so as we see in this network, how many meshes are there? So there are two meshes. Okay, so see, suppose I am writing, I am giving naming to the nodes. Okay, A, B, C, and suppose this is D. Okay, so how many meshes are there? There are two meshes. All meshes are loop, but all loops are not meshes. Okay, so this all meshes are loops. Okay, but all loops are not meshes. So here, how many meshes are there? So A, B, D, and A. Okay, so so this is first mesh. Okay, so then B, C, D, B. So this is the second mesh. These two are the meshes. Okay, so these two meshes can be called as the loops also. Okay, so but if we consider A, B, C, D, and A, suppose we are moving in this direction. Okay, so then A, B, C, D, and A. Okay, so this is loop, this is not mesh. Okay, so this is the slight difference between loop and mesh. So now we will move to the further. This is the very simple question. Here we will see first that how this given question can be solved by the conventional methods that we were using. Okay, then we will apply mesh analysis to the same network. Okay, so here 10-volt source is connected. Okay, here 10-volt source is given. This is 10 ohm resistor R1, 20 ohm resistor R2, and 40 ohm resistor R3 is there. Okay, so if we apply the methods that we are knowing up to now, okay, apart from mesh analysis, so here suppose we are considering that current I1 is being given by this source. Okay, so 10-volt source is giving current I1 to the circuit. Okay, so here this is the 10 ohm resistor and current I1 is being flown, that is given by the 10-volt source. 10 volt, this is the DC source. Okay, so now here this is the 20-volt source also. Okay, so now we had assumed that this 20-volt source is giving current of I2 to the given network. Okay, so now I1 is the current here and I2 is the current here. Okay, so I1 is the current given to this network by 10-volt source and I2 is the current given by network by the 20-volt source. So now by simple observation at this node, this is the node. So what will be current I1 is incoming, current I2 is also incoming. So both current I1 and I2 will go through this R3. Okay, so current through R3 is I1 plus I2. So now question is we will have to find the value of currents I1 and I2. Okay, so here we need to calculate the currents I1 and I2. So now by simple observation of the network only, we had concluded that the current through the R3 is I1 and I1 plus I2, summation of I1 plus I2. So now simply we will apply KVL. Okay, so now if we write down the equation in this path, suppose if we are considering this path, okay, so now what will be the value of the voltage drops? Okay, what we do in KVL means we will have to write the voltage drops in the given network and algebraic sum of voltage drops is equal to 0. So now what is the current through this 10 ohm? That is I1. Okay, so now voltage drop across this network element is 10 I1. Okay, so now we are here. Okay, for R3 what is the voltage drop? Voltage drop is 40 into I1 plus I2. Okay, 40 into I1 plus I2 because current through that is I1 plus I2. So here two conventions may be followed. So as per one convention, we write voltage drop as negative because that is drop, and in one convention we write voltage drop at positive. And then if in according to this convention, if we go from this terminal to this terminal of source, that means if we go from negative terminal of source to the positive terminal, so that will be taken as negative, okay, according to this convention which I am following here. So you can write equation as per your convention, okay. So here 10 I1 plus 40 I1 plus I2 minus 10, okay, minus 10 equal to 0. So now this equation we can write simply this as 10 equal to 50 I1 plus 40 I2, okay. This is the equation that is written over here, okay, equation number 1, okay. So in similar way we can write equation in second mesh also for the second path, okay. So if we write equation over here, then we will go in this direction, okay, because we will move in the direction of the current. So now what will be the equation here? So there is 20 I1, because what is the voltage drop in this element? That is 20 into current is I2, so 20 into I2. So similarly we had written earlier also what is the voltage drop in R3, R3 into I1 plus R2, I2. So R3 is 40 I1 plus I2, okay. So now for this element, for this 20 volt source, we will write minus 20, this is equal to 0, okay. So now after simplifying this, we will be having this, sorry, this will be I2, 20 I2 plus 40 I1 plus I2, okay. So this is 20 I2 because 20 is the resistance and I2 is the current through this, so 20 I2. So now what is the simple equation? That is 40 I1 plus 60 I2 equal to 20. This is the second equation that is written over here, 40 I1 plus 60 I2 equal to 20. So now we are having two equations, we need to calculate two unknown, okay, that is I1 and I2. So after simplifying this, you can easily find out the value of I1 and I2. So this is the conventional method that we are following, okay. So what we do here, we in this conventional method we trace the current through each element, okay, and then we apply KVL, okay. So but approach will be slightly different if we go for the mesh analysis. How? So here this mesh analysis will make the circuit solution easier. How? So it is the easier method for solving the circuit, okay. So mesh current analysis or loop analysis, okay, so that we had discussed, that this is also known as loop analysis. It is also sometimes called as Maxwell's circulating currents method, okay. So this mesh analysis is also known as Maxwell's circulating current method, okay. So instead of what we do in this analysis, instead of labeling branch current, instead of labeling a current through each element, we label current in the mesh, okay. We label current in mesh, individual current. So now after labeling individual current in each mesh, we write the Kirchhoff's voltage law equation, okay, that we used to do earlier also. So it will be make them easier. How? So advantage of this method is that it ensures that the information obtained from the circuit equation is the maximum required to solve the circuit, okay, and is more general and can be easily put into the matrix form, okay. In this matrix mesh analysis, we see how and why this mesh analysis is making the circuit solution easier, okay. In this method also we are applying KVL, okay. Instead of writing branch current, we are writing mesh current, Okay, and then we are applying the same KVL. But why this method is making solution easier, that the mesh equations, okay, the mesh equations that we write, those are the those are the equation that are the information, okay, obtained from the circuit equation, which are, those are the minimum requirement, okay, those are the minimum information of the of that given circuit, okay, and is more general, okay. Okay, so this makes this analysis easier, because mesh equations are the minimum information, that minimum and general information of the given circuit, okay. Also, in mesh analysis, we can directly write the network values, or we can directly write the mesh current, mesh equations in the matrix form also, that we will see, okay. See, the same question is there, okay, the same network that we had considered earlier, that is again considered here. What we are doing here, okay, in that question we had taken, in earlier approach we had taken current I1 through this branch, through this network element, current I2 through this network element, and then I1 plus I2 through this R3, okay. So that was the earlier approach. So now what we are doing here in mesh analysis, we are considering individual mesh current, okay. So in this circuit there are two meshes, okay, so two meshes are there. So for individual mesh we are taking a mesh current, individual mesh currents is being considered, okay. So now here, see, this is the mesh current I1, okay, so this is the mesh current I2. Both mesh currents are taken into clockwise direction, okay. So concept is that instead of visualizing the source connected in the mesh, we will consider mesh current in same direction. If we are taking anti-clockwise direction in one mesh, then in other mesh also we will consider current, mesh current in anti-clockwise direction, okay. But if here we are taking current in clockwise direction, so in all meshes currents will be considered in clockwise direction, okay. So now write equations in matrix form directly, okay. We can write mesh equations directly in matrix form. How? See here, if we consider mesh 1, okay, so now what is the current? Now put the values, we will be having I1, I2, okay. So now see, if you see the mesh current I1, okay, so this I1 is facing how many resistances? That is the individual resistance. For this individual resistance, for this current I1, okay, that is not linked with I2. So individual resistance for this network is 10 plus 40, that is 50, okay. So for simplicity, you can write this also 10 plus here, you can write this as 10 plus 40, okay. So now see, if we are traversing in mesh 1, okay, so here current I2 is also there in this 40 ohm resistor. So now see, what is the resistance that is linked between these two meshes, okay. So write that with negative term, okay. So that is, what is the resistance that is linked with both I1 and I2? That is 40. So we will take negative sign of that, okay. So now in this second mesh, what is the current, what is the resistance that current I2 is facing. Current I2 is facing for this individual mesh. So that is 20 and 40. So write that as 20 plus 40. Okay. Now see what is the current, what is the resistance that is linked between I2 and I1. So again that is 40. So write that with negative term. Okay. So now see, now for writing the values of this side, now you just see the direction of current through this source. Okay. So in this current I1 is traversing, okay, this current I1 is being circulating in this direction. That means it is being out from the positive terminal of the source. Okay. So it will be taken as positive. Okay. So now see this mesh current. Okay. So this mesh current is, we can see it is terminating at this. Okay. So it is starting with here, but here in this case it is starting with this and terminating with this 20 volts positive source. So we will write this as negative. Okay. So this is the mesh equation for the given network. So now you can solve this, okay, and you can find the value. Okay. So it will be 50 minus 40 and 60. So by applying any of the matrix solving method, you can find the value of current I1 and I2. Okay. So next, here this has been solved. V equal to I into R. So this is the method that we had calculated the mesh currents, okay, by the mesh analysis. In mesh analysis, what is the advantage? That we can write mesh equations directly in matrix form. Okay. So this is the 2 by 2 matrix. Okay. So there will be, if there will be 3 meshes, then the matrix, this matrix will be of 3 by 3. Okay. So that will also be written easily by visualizing the network only. Okay. So we see what is the value. Again, if we generalize this, we can write this as, suppose this is R11, this is R12. Okay. So this is R21 and this is R22, nothing else. This R11 means resistance that mesh current I1 is facing for the first mesh individual. So that is 10 and 40. Okay. So R12, that means resistance that is linked between mesh current I1 and I2. So that is the 40. So here we are taking this as negative. Okay. Similarly, this is R2, that is 20 plus 40. Okay. So this is the simple approach, and after solving this equation, we will be having the value of current I1 and I2. So here a simple method for solving the equation has been considered here. You can apply the Cramer's rule also. Okay. So here what has been done, that I is V by R, that means I is R inverse V. This is the R matrix. So we will calculate first inverse of this matrix, for which, so this has been considered, this is the inverse of resistance matrix, and then inverse R into voltage, that is 10 and minus 20. It will give the value of the current. See here. So this is the I1 and I2, that this we had calculated in this slide, that R inverse is this. Okay. So now you just put the value of V, that is 10 and minus 20. So now you can easily find the value of I1 and I2. You can directly apply Cramer's rule also. Okay. Suppose what is the advantage of matrix approach for solving equation is that, if suppose in this case, if you need to calculate only current I2, okay, or you need to calculate the current I1, okay, suppose only one current is needed for your solution, so then you can directly apply Cramer's rule. Okay. So according to Cramer's rule, this R is the value of this will be calculated, and then if you need to calculate the value of I1, then you will just replace this first column with these elements. Okay, so that value of that matrix divided by this total matrix, this will give the current I1. Simply, if you will have to calculate the I2, then you will replace the second column with these values. Okay. So now here if we analyze the question that we had solved using the mesh analysis, so what is the V? V matrix is the total battery voltage for the loop 1 and then loop 2. So I is the mesh current or the loop current that we are required to calculate, and R is the resistance matrix. Okay. So suppose if you need to calculate, suppose in this question, if you will have to calculate this current that is through this 40 ohm resistor. Okay. So that, see, what is the value of I1? I1 is minus 0.143 and I2 is minus 0.429. Okay. So then you will calculate the algebraic sum of these currents. Okay. So one current, see here in this network, this current I1 is in this direction, the current I2 is in this direction. Okay. So you will calculate I1 minus I2. Okay. So it will be in the downward direction. So I1 is minus 0.143 and I2 is minus 0.429. So minus 0.143 minus 0.429, it will give you 0.286 ampere. Okay. So now what is the basic process? Now we will summarize this. So basic process for solving the mesh analysis technique is that first we will label all the mesh with the circulating currents. Okay, we will label all meshes with mesh currents. Then we will write column matrices for currents and for the sources, voltage sources. Okay, so then you need to write the resistance matrix. Okay, so resistance matrix, rules for writing the elements of the matrix, rules for writing the elements in the resistance matrix is shown here. R11 up to Rn. Okay, so R11, R22, R33 and Rnn, these are the total resistances of the individual loop. Okay, suppose we need to write the R33, that means total resistances in the third mesh. Okay, so RJK, R12, R21, R23. Okay, so these are the resistances which will be the resistances adjoining the two meshes. Okay, suppose you have to write R23. Okay, so what is R23? R23 is the resistance which is directly joining the mesh 2 and 3. Okay, so that matrices will be written. Okay, all matrices you can write, and matrix you can solve by Cramer's rule or by simple calculation, you can opt for that. Okay, so but applying Cramer's rule will be advantageous when you will have to calculate only one current. Okay, suppose three meshes are there, then you will be having three equations. Okay, so 3 by 3 matrix will be there, and suppose you have to calculate only I2. Okay, so suppose you will have to calculate the power through any resistance, and through that resistance current I2 is flowing. Okay, so then you don't need to calculate I1 and I3, you will have to calculate only I2. Okay, so I2 square into value of that resistance will give the power absorbed by that resistance. Okay, so this is the advantages. So here this case the current source is existing in only one mesh. Okay, so here current source is existing in this mesh you cannot write the KVL. Okay, why? Because how you will write the voltage drop in this element? Okay, so you cannot write. So this is the case of the super mesh. Okay, so what you will do here, see, in first loop equation has been written. So in this loop you can directly say that suppose you have considered I2 in this direction, that means I2 is minus 5. So you don't need to write a loop equation here. Okay, so it is simple. Okay, so second case, the case of the super mesh. Okay, what is the difference is that here in the adjoining branch current source is there, then how will you write the KVL equation? It is not possible to write the KVL equation. Then you can apply source conversion. You cannot apply source conversion because this is the current source and in series there is resistance. Okay, so then how will you write mesh equations? See, you will have to exclude these two elements. Okay, see, you had considered current I1, you had considered current I2. Okay, so now by observing it only, you can write I2 minus I1. See here, I2 is in this direction, I1 is in this direction. See, this is I2, this is I1. Okay, so only I2 minus I1, you can write this as 6. Okay, one equation is already there. Now you just apply KVL through this as shown here. Okay, so how you will write? So 6I1, 6I1. What is the current, mesh current here? 10I2. So 10I2, 6I1, 10I2. Again, what is current here? I2. So 4I2 minus 20 equal to 0. So you are already having an equation in terms of I1 and I2, and you will find the second equation. After solving these two, you will get this value. Okay, so these are the different cases that can be given through the network. Okay, so network may be of any type, but you can apply mesh analysis. Okay, only minute observation is needed. So see here, this is the circuit with dependent sources. See, this is the circuit with the dependent sources. Okay, so then what is this? This is the current dependent voltage source. So you can write the KVL equations, no problem. Okay, so by simple method here, what has been done? Two mesh currents I1 and I2 are considered here. Okay, so now you just write KVL equations, no problem. Consider this is source, this is the voltage source, current dependent voltage source, no problem. And this this value of current over which this Ix, this 10Ix, okay, this voltage dependent voltage source is depending on current Ix, and you can write the value of Ix in terms of mesh currents. Okay, so see here, Ix is in this direction. Okay, so I1 is in this direction through this branch and I2 is in this direction. So now correlate these things. So what is the value of Ix? Ix is I1 minus I2 by simple observation. Here, see, this is the equation. Now write KVL equation in each mesh and solve these equations. So this is the equation for the first mesh, this is the equation for the second mesh that is written over here. Okay, so now after solving these equations, you will be getting I1 and I2. So mesh analysis can be applied. Okay, so this is the another example. Okay, here see, this is the voltage dependent voltage source. Okay, so this is the voltage dependent current source and this is the current dependent voltage source. This is the current over it which this source is depending. Okay, so in this case also you can apply. How many meshes are there? See, if you see 1, 2, 3, 4 meshes are there. Okay, so now you will have to consider the currents, four mesh currents initially you will consider. Then you will see where you can write equations, KVL equations, and where you cannot write KVL equations. Okay, so the place at which you cannot write the KVL equation, you can directly correlate the mesh currents. Okay, so like if you consider I1, I2, I3, I4. Okay, so now see, you can correlate the things. Okay, so this is the solution that is also provided here. So after simplifying, you can get these values. So you can practice over this question. Okay, so again this question is some numerical problems are provided here. You can practice. Okay, and then go for this. Thank you.